Hello, everyone, and welcome to Octane 21 into the Security Roadmap session. I'm Grace Wardana, Senior Director of Product Management, and I'm joined here by my colleagues today, Thomas Dusing, Tomer Mayara, and Tanha Nguyen. I'm excited to show you the rich security capabilities that our teams have built on the Okta platform to help you achieve the security outcomes that you're looking for. To kick things off, I'm going to start with our approach to security. At the keynote and other sessions, you may have heard us talk about Okta as the identity cloud. You may be wondering what role does security play as part of the identity cloud and where directionally are we headed? I'll start with saying that at Okta, we see security as critical and non negotiable. Security serves as the foundation of trust for every enterprise and beyond. Three tenets to share. We take an identity-centric to zero trust security. This means that we use identity, whether it's user and or device, to bridge the other components of the extended ecosystem. We're building security as a platform service. We know our customers have existing security tools that they want to leverage with Okta. By staying independent and neutral, we will let customers pick and choose best-in-class integrations. Next, we are extending our coverage into more resources and more use cases, two areas that we'll cover in this session. Okta Privileged Access, which was announced today, leverages advanced server access to give you a central control plane for managing access across critical infrastructure resources. Finally, we're extending authentication beyond app login. This means being able to issue an MFA challenge in-app post-login, as well as integrate claims from external integrations to provide customers with more flexibility and more options. I'd like to walk through our approach to zero trust. We start out with user identity and device identity as the foundation to bridge the other components in the ecosystem. We then consider contextual signals, whether Okta-specific or third-party. All this factors into the access decision. I'm going to tee up four areas that we'll cover in this session. Each is a product or platform service that plays a role in access decisions. First off, we have advanced server access and now Okta privileged access, which gate Okta users access to infrastructure resources. Okta privileged access expands on advanced server access capabilities by enabling you to protect more resource types such as databases and Kubernetes clusters. Next, we'll talk about the platform services that address risk and deterministic policy. On the risk side, we have ThreatInsight, which is our first line of defense against large-scale attacks. ThreatInsight is aimed at attackers that cast a broad net while trying to get a user's valid credentials. Okta's Risk Engine mitigates targeted attacks where a malicious actor might have access to valid user credentials. We are expanding Risk Engine into a risk ecosystem to cover more sophisticated attacks using signal exchange with partners. Last but not least, we have the Policy Engine, which governs and orchestrates all decisions around authentication. We're now expanding the engine to include external authenticators and claims providers. Collectively, these products and platform services determine access to various resource types, whether infrastructure, apps, or APIs, all within a unified identity control plane. I hope that broad overview gives you context for the three exciting topics we have lined up for today: advanced server access and Okta privileged access, threat insight and risk ecosystem, followed by a policy engine. I'm now going to invite Thomas Dusing to the stage to tell us all about advanced server access and Okta privileged access.
Thanks, Grace. Before I dive into the roadmap, I want to talk briefly about 2020. Unlike most of us, or maybe it was just me, Advanced Server Access had a great 2020. The sustained work from home trend led to significant increases in SSH and RDP logins, with SSH logins through ASA increasing more than 900% year over year. From a feature perspective, we launched SSH Session Capture in early availability recently, which also introduced the ASA gateway as a new and improved Bastion construct. In addition to SSH Session Capture, we also released enhanced user attributes and the ASA connector for Okta workflows in 2020. Our focus on security and compliance remains strong. The ASA platform is now SOC 2 Type 2 and PCI DSS compliant. And on the scale front, we continue to sustain both actual and simulated load throughout the year, with our stress test taking us well past the million server watermark. As you heard from Todd earlier today, Okta is officially breaking into the privileged access management market, and we're doing it the Okta way: simple, cloud-based delivery with an emphasis on the features you need and use. With Okta privileged access, we are not building a product for the way people used to work or the way that infrastructure used to be. We're building it for the way infrastructure is today and will be in the future: cloud native and just in time, the way critical infrastructure access should be. And we won't only restrict ourselves to servers, but we'll also extend to secure other privileged resources such as databases, Kubernetes clusters, and more. Okta privileged access will be available in the first quarter of 2022. I should also note that the features I'm about to cover will all be available as part of advanced server access, as the product exists today when these features launch, but they'll also be a part of Okta privileged access in the future. Since the early days of advanced server access, we've been focused on serving dynamic workloads at scale in the cloud. We're taking that to the next level with IaaS inventory integration. We're making fleet management easier by importing your server inventory and its associated metadata from AWS and GCP. This helps you answer questions like, which servers are not enrolled in ASA? Which servers are enrolled in ASA? What does my fleet coverage look like right now? This feature allows you to securely link multiple cloud accounts to projects and advanced server access using cross-account roles. This means you get to stay in control of the data that Okta can access when you establish that trust relationship. Finally, the metadata we sync from AWS and GCP will allow you to drive server access policy, which I'll talk more about later.
Now I'd like to demo our new infrastructure as a service integration capabilities for advanced server access. In this demo, we'll link an AWS account to our ASA team. In order to securely import the server list and associated metadata from AWS, we need to set up what's called a cross-account role. Essentially, we're granting read-only API access to ASA, scoped specifically to EC2. This is a standard process for AWS account administrators, and it keeps the customer in control of exactly what data they want to make available to Okta. Once we've created the cross-account role, and we only have to do this once per AWS account, we can establish the link between our AWS account and our ASA team. I'll also note that this isn't just a one-time data dump. Server data is synced regularly as customer infrastructure scales up and down. What you see here is a list of all the EC2 instances on our newly linked AWS account and their associated metadata. This is interesting and important for a couple of reasons. First, customers can now get a complete view of their server fleet in the ASA web console. They can now see at a glance which servers are enrolled in ASA and which aren't. Second, we'll soon be using this label metadata as part of our policy sync feature family to enable attribute-based access controls on a per-server basis, allowing our customers to reuse the investments they've already made in tagging their cloud infrastructure.
As Okta, we make a strong promise of availability, 4 nines, the first in the industry. But we know if the situation arises that Okta or advanced server access were to go offline, it's more than just inconvenient for you and your teams. So today I want to introduce disconnected mode, which will enable designated administrators to access servers even in the event that the Okta platform is not reachable. In order to do this, we're leveraging our existing CA architecture to enable administrators to mint longer-lived certificates that can only be used in the event of an emergency. Disconnected mode will arrive in beta early in the second quarter of the year. As I'm sure you're aware, ASA supports RDP connections to Windows servers today, and we've seen healthy adoption of this feature, particularly among managed service providers and in contractor use cases. However, we've heard loud and clear that most enterprise deployments of Windows Server make heavy use of Active Directory joined users, specifically for policy and permissions management. In supporting AD joined users, Advanced Server Access is standing on the shoulders of an Okta-sized giant, leveraging Okta's existing directory consolidation and integration toolset. This allows admins to link multiple Active Directory identities with their singular Okta identity, while adding Advanced Server Access as the authoritative access control point for all of your Windows servers. I like to think of it as the best of both worlds, the identity-backed access control of Advanced Server Access with the robust and proven on-server policy of Active Directory. Domain-joined user support will be available in early access in the second quarter of the year, but let me double-click on the rollout plan a little bit more before moving forward. As I mentioned, our early access target for AD joined user support is the second quarter of the year, but we'll also be rolling out enhancements throughout the rest of the year. Specifically, I want to call out RDP session recording, which leverages the ASA gateway and our new RDP proxy to capture all actions taken in an RDP session. Last up, I want to talk about Policy Sync. Policy Sync is a framework we introduced at Okta Showcase 2020 that enforces least privilege access across dynamic infrastructure at scale. Policy Sync has three components: role-based access control, attribute-based access control, and time-based access control. Each of these components natively integrates and syncs with authoritative data sources. For instance, ASA's role-based access control sync with Okta's universal directory via SCIM, syncing users, their attributes, and group memberships to ASA while maintaining a single source of truth for that data in UD. Today, though, I want to focus on attribute-based access control. Policy Sync's attribute-based access component will allow you to deploy granular access controls across dynamic fleets of servers at scale based on their labels. These server labels can be managed in ASA directly, or, like you saw in the demo earlier, they can be imported from IaaS providers like AWS and GCP. You can see in the example here that we have 3 servers, each with 3 labels, each label expressed as a key value pair. Each group can express their attribute-based access controls using selectors. In this example, we can see the SRE group can only access web servers in the production and QA environments, and the DBA group can only access databases as long as they're not in the EU. This flexibility allows administrators to map server access more cleanly to their organizational structure while ensuring least privileged best practices. Policy Sync's RBAC component will be released into early access in the second quarter of the year. I want to zoom back out to take a look at Advanced Server Access in the context we established up front. Advanced Server Access is focused on delivering secure access to infrastructure resources across the enterprise, but more importantly, it builds on top of the foundational Okta authentication platform. To talk more about the ThreatInsight and risk ecosystem elements of the platform, I'd like to invite Tomer to the stage.
Thank you very much, Thomas. In this section, we'll cover ThreatInsight and our brand new risk ecosystem. Before we dive deeper, I would like to highlight 2 key components. First, ThreatInsight is Okta native large-scale attack mitigation tool. ThreatInsight protects only Okta endpoints. It doesn't protect the non-Okta parts of the app, and it serves as the first line of defense. The vision is to stop most threats here, with focus on large-scale attacks. The risk ecosystem is an expansion of Okta Risk Engine. The risk ecosystem improves Risk Engine ability to mitigate the most sophisticated targeted attacks. Our vision includes stopping phishing attacks and detecting compromised sessions post-authentication. We are also looking to enable long-lived sessions. A key component of being able to deliver on this vision is an ecosystem of best-of-breed security providers. We will cover how Okta exchanges signals with partners after discussing ThreatInsight. So let's start with ThreatInsight, what we've done last year and what is new. We've expanded ThreatInsight mandate to cover all relevant Okta assets and to deal with large-scale attacks on Okta authentication, recovery, and enrollment flows. We also introduced a lot of improvements this year, most of them under the hood, but the effort already pays off. This year, we've seen a massive increase in the magnitude of attacks. The largest one, which was mitigated by ThreatInsight, involved billions of requests and around 700,000 unique malicious IPs. A feature which we are really excited about is our new machine learning model. This model is designed to detect when an org is under a large-scale attack, like the one mentioned in the previous slide. ThreatInsight traditionally is taking a more conservative approach when blocking IPs. However, while an org is under attack, we want to switch to a more aggressive approach to mitigate the attack faster. This is where our new ML model comes into play. First, we determine the traffic baseline for each org. When we detect a significant anomaly, we automatically switch ThreatInsight to a more aggressive block mode. We also create a syslog event notifying admins of the ongoing attack. When the attack is mitigated, we switch back to a more conservative mode. With that, let's now switch to Okta Risk Engine and the Risk Ecosystem. As a quick reminder, Risk Ecosystem is an expansion of Okta Risk Engine. The ultimate goal is to deal with compromised sessions post-authentication and enable long-lived sessions. There is a simple but powerful premise beyond the ecosystem. Okta has a broad view of person's identity across different apps. We see the user at key points in the user's lifecycle: enrollment, authentication, etc. Network access providers, security stack, and fraud mitigation solutions all have a deep and specialized view of specific threat in the context of a specific app. This is a synergetic, better together view of the world. Okta is aggregating partner signals and correlating them with users' identity. Okta then shared back the aggregated identity risk with the ecosystem. This magnifies the effectiveness of each individual component of the stack. We are going to split this section into consumer and workforce identity. Each part has a slightly different type of partners. Let's begin with consumer identity. Here is what we hear from our customers. From user experience perspective, our customers have three goals. First, reduce the chance of security stack blocking legitimate users. The security stack should delegate to Okta for a step up when possible. Second, reduce MFA during primary authentication. And lastly, the holy grail, never terminate user session or at least extend session lifetime significantly. From security perspective, it looks like our customers' main focus is shifting away from simple account takeovers to more advanced threats. If customers want to facilitate long-lived sessions, we must be able to detect and mitigate compromised sessions post-authentication. In other words, customers are looking to implement continuous authentication in a real and practical way. Another important aspect that is sometimes overlooked is time to value. Okta works with partners to do all the heavy lifting around integrations. Our ultimate goal is to get as close as possible to one-click integration. Let's flesh out these points with a few demos and announcements. Let's jump to our first demo.
For the first demo today, I'm joined by Rob of Signal Sciences, which is now part of Fastly. Hey Rob, before you jump us into the demo, can you give us a few seconds on Signal Science and Fastly?
Absolutely. Thanks, Tomer, for that intro. And yeah, hi, everyone. I'm Rob Gibson. I'm with Signal Sciences. And Signal Sciences, in case you don't know, is a next-generation WAF and RASP solution acquired by Fastly in October of 2020. Our solution can be deployed in minutes to defend any application on any stack and is fully API-driven with a large and growing list of DevOps toolchains that we can integrate natively into. We provide our customers with protection from any web application and API threat. And so I'm really pleased today to introduce our new integration with Okta's Risk Engine, which will ultimately help provide an additional strong layer of protection from these threats to our mutual customers. And so I'm just going to dive into the presentation here. We're going to focus in this demonstration on IP addresses. And I think we all know in this audience that IP is not always the best identifier to focus on when tracking clients engaged in nefarious behavior, but it can be quite useful when in many scenarios, it's kind of the lowest common denominator. And we're looking for threat patterns and means of intervention. And when doing so, it helps to look at the ecosystem bad actors are using to execute their attacks. One element of this are large-scale botnets consisting of a large number of compromised, often residential machines. And the controllers of these networks rent out network space and compute power to other malicious actors, which gives them easy access to a large number of IPs, but also means that they end up re-renting the same IP to multiple unrelated attackers. So when you look at services like Fastly and Okta, you can see that we are uniquely positioned due to our large footprints and the network effects they provide to impair the economic incentives of these botnet operators. So at a high level, in this example, we're going to use Signal Sciences / Fastly to quickly identify and flag malicious IPs and notify Okta about their risky behavior. And then Okta can, instead of blocking, enforce authentication restrictions, which will reduce false positives and allow for a more aggressive and more targeted enforcement stance on both Fastly and Okta. So drilling in a bit more, let's take a look at this example. We're going to look at an e-commerce app that has an unauthenticated guest checkout flow protected by Signal Sciences, as well as authenticated pages behind Okta with more sensitive information. So on the unauthenticated pages, the apps are vulnerable to credit card enumeration, where attackers may try to abuse the app to help validate lists of stolen credit cards. And of course, authentication is exposed to account takeover attacks. So in both cases, though, the attacks may be initiated by different actors, but leveraging the same botnets. So I'm going to dive into the demo and show you how such an attack scenario might look from the point of view of a security practitioner. I'm going to show you how easy it is to use Signal Sciences and Fastly to defend against this, and then pass it to Tomer, who's going to show you what it looks like on the Okta side. So I'll start by showing the Signal Sciences console. And it's very easy to configure your Signal Sciences workspace to detect and defend against these types of attacks. So I have a demo application behind this Signal Sciences workspace. And I'm going to go first into our templated rules and set up some rules to detect potential credit card enumeration. The other rule to configure is the failed credit card validation attempt. And it's the same concept here, telling Signal Sciences if you see a signal of credit card authorization attempt and a response of 404 from the server, that represents a failed attempt to authorize a credit card. And there's just one final step here to set this up. I will create an alert. And this alert is going to say, if there are 5 failed attempts to authorize a credit card in a minute from an IP address, I'm going to flag that IP. I've already configured my workspace to alert Okta if an IP gets flagged with credit card failure to authorize a credit card. So in this case, I have a pretty simple curl loop that's going to run through a list of just fake credit card numbers and try different numbers on my application. Basically, Signal Sciences is detecting these requests as they're coming through and tagging each request with these signals that we just configured. And the Signal Sciences Cloud Engine is going to count them up. And when they cross a threshold, they're going to flag the IP for Signal Sciences and alert Okta. And you can see those already coming through. So here are requests from my demo IP address. They're getting tagged with the credit card attempt signal and the credit card failure signal. So you can see a few of those having come through here on the West Coast at 10:20 a.m. this morning. And I'll go into my events page where you will see that just a few seconds ago, this IP has been flagged. And so Signal Sciences is tracking further requests from those IPs. And behind the scenes, we've sent a notification to Okta about the riskiness of this IP. So I'll pass it over to Tomer from Okta to see what that looks like.
So let's have a quick look on how it looks like from the Okta side. So normally customers are trying to reduce friction. They usually set MFA only on high risk logins and leave lower risk logins without MFA. If we really jump really quick to the syslogs, here is the syslog event indicating the signal we got from Fastly. And if we scroll down, you can see my IP address is marked as high risk. If I try to authenticate, I'm gonna get prompt for an email OTP. This is when a large-scale account takeover attempt is usually mitigated. But let's assume for a second that this authentication attempt is successful, and let's check the sign-on event in syslogs. Here's the sign-on event. If I scroll down, you can see that this authentication event is marked as high risk. And one of the reasons is the signal we got from Fastly indicating my IP address as high-risk IP address.
In the next demo, we are going to show how our partner ecosystem facilitates continuous authentication flows. Here, we join forces with WideOps. WideOps is embedded within the app and has a deep understanding of advanced threats. When a suspicious activity is detected, WideOps is terminating the session and delegating back to Okta. On Okta side, we run a high-risk authentication policy to determine whether the user is allowed to proceed. I'm joined today by Mike, WideOps Chief Product Officer, and Frank, WideOps VP of Solutions Engineering and Sales. Hey Mike, can you please give us a quick overview of WideOps and take us through the demo?
Thank you, Tomer. I'm Mike. I'm from WideOps, and we disrupt cybercrime at scale. We know that most cybercrime today is committed via compromised home machines and at scale through botnets. We do this today for the largest platforms on the internet, and we do it more than 10 trillion times a week, where we verify the humanity of an online interaction. We determine whether something's a bot or not. We determine whether the device is malicious. We determine whether the interaction doesn't appear to be a human. We believe we're good at this because we have superior detection techniques. So we look at network protocol, browser, identity, behavior-based signals. We have a large network effect. So when you're working with us, you're benefiting from the collective protection of some of the largest platforms on the internet. And we have a research team we call Satori that does hacker intelligence and takedowns. So they're continuously looking at the criminal groups. They're doing research against them, and we're using the information that's gathered from that team as first order data that drives our machine learning and our detection algorithms that give us a very good false positive, false negative performance. We're excited to be talking about how we work with Okta because we believe we've likely already seen 80% of your users previously. Because we have such a broad footprint across the web, we expect that we've already observed most of the users that interact with your application through our collective protection, meaning we can very quickly reduce the risk of your user's authentication event, whether their account's been compromised because their username and password has been stolen, whether their device is compromised because they're running malware, which we'll go through in a demo in a minute, or they're actively writing Selenium scripts on their own and attempting to compromise your application. Frank is going to go through a demonstration where we continuously assess the hygiene of the connection to an application. And when we detect that that hygiene has gone awry, because our collective protection has detected this, we interact with Okta, log the user out, and then protect the application from that user and from that interaction across the entire Okta ecosystem for that customer. So with that, why don't you take it away, Frank?
We're going to start out by just looking at an application that's defended by Okta for login. Here we're logging into an application. This one's called Sales Impact. And in this case, we're witnessing beneath the hood how Okta's auth API was called, and subsequently we reached into the application. You could see on the Okta side that we applied a default rule to the access to the application. Here we are again back at the login application. We're adding a Chrome extension to the browser. We've seen a lot of evidence where Chrome extensions evade endpoint protection products and introduce automated bot-based activity. This Chrome extension, our user thinks, is just helping them add 2 numbers, but beneath the surface, this Chrome extension is actually being used to exfiltrate customer information directly from the user session. Now let's repeat the same attack, but this time let's repeat it with white ops present on the application. Here you see white ops continuously validating what we refer to as signal, device, interaction, network level communication that's occurring. And here when our user goes to use this malicious Chrome extension, immediately as they do, we're going to see that white ops detects the interaction as automated as a form of bot-based activity and subsequently immediately logs our malicious user out of the application. At the same time, the Okta platform receives intelligence that allows all of Okta's customer applications in this instance to actually be smarter and react to this device that was compromised. Subsequently, when our user goes and visits any Okta login interface, or in this case, our Sales Impact application, white ops is denying login, and across the entire Okta application pool for this customer, we're stepping up the authentication and adding a multi-factor one-time password delivered to their email. And this is really the incredible capability that we could achieve together with Okta.
Thanks, Frank. Please be sure to visit our booth on our website, whiteops.com.
Another aspect of continuous authentication is enabling long-lived sessions without compromising on security. I'm excited to announce a deeper partnership with F5 Shape Security. In this case, specifically for Okta customers that implement the refresh token flow. Together, Shape and Okta improve the ability to detect and mitigate threats post-authentication, which facilitates a longer application lifetime and reduces end-user friction. On the topic of deepening the partnership with F5, we are also working on integration with Nginx, one of the most widely adopted web application platforms. There is a very powerful aspect to this partnership. Nginx and Okta together are creating a risk-aware gateway both from threats and identity perspective, which will eventually take us beyond continuous authentication, moving us closer to continuous risk-based authorizations. Now let's move to the workforce identity side of the house. As with SIAM, we are taking continuous authentication from theory to practice. Last year, we announced partnership with EDR vendors vendors, and we are working to deepen our relationship with other security vendors like RBAC solution, specialized solution like Proofpoint, and network access providers like Zscaler and F5. The partnership that I'm personally most excited about are SaaS app native security components. Top-tier SaaS apps often offer a native DLP, which is a data loss prevention, and threat detection tools. These security tools can leverage Okta identity risk when enforcing in-app logic. To make it more concrete, I'm excited to announce our partnership with Box. Box Shield is the native Box app security component. On one hand, Box Shield has a deep understanding of users' security posture within Box app. On the other hand, Okta provides a wide perspective into how a user behaves across different apps. There is a very interesting interplay here, which we are looking to implement with all leading SaaS apps. Box Shield leverages Okta to improve in-app behavior-based threat detection. Okta benefits from visibility into user activity post-authentication, moving closer into effective continuous authentication. All right, let's summarize. Building an ecosystem is a multi-year journey. Naturally, we start with IDP flows like authentication, but we are starting to expand beyond this point. We want the ecosystem to cover the entire app surface. We are also starting with IP risk and data we gather ourselves as an IDP. And we are already working with partners to expand to a more holistic approach. That concludes this section. Now I would like to invite Tana to discuss Okta Policy Engine.
Thanks, Tomer. In the final part of this presentation, we'll dive back into the core Okta policy engine. Going back to our architecture diagram, whenever you need your users to authenticate, whether it's app login, infrastructure access, or a prompt from Okta's risk ecosystem, authentication and policies will be handled by Okta's core policy engine. Let's start with the key problem statements and a brief overview about how we're solving this. We've heard that you want to use the best-in-class tools for your organization and that you want to integrate device management, risk, and authentication solutions that fit your users' needs. Okta's role is to integrate any signal that our admins bring to us. Last year, we released authenticators and assurance. This year, we're building out the ability for you to map your integrations to assurance, building towards a vision of a catalog of authenticator integrations. Secondly, we know that you want more frequent policy evaluation, with the end goal of continuous authentication. Last year, we introduced per app and recovery policy. And this year, we're building out in-app step-up authentication, building towards our vision of requiring user authentication only on context change. Finally, we know that detection and response to security threats is not enough. We have heard that you want increased visibility into and reporting on what is going on in your account, both as an end user and as an Okta administrator. Today, we have built end user tools for viewing account activity. And this year, we're building proactive notifications towards a vision of a security event dashboard and notifications. Let's start with the problem statement of integrating any signal. Today, in limited early access, we've launched authenticators, a new concept in the Okta platform for describing authentication methods. While you may already be familiar with Okta's factors, authenticators are an extension of factors, bundling together the factors that come together as a package. For example, the Okta Verify app is a single authenticator that users enroll. The Okta Verify Authenticator bundles together TOTP, push, and our new cryptographic proof of possession authentication methods. Whereas factors in Okta were all treated equally, for example, security question could be prompted in place of security key, authenticators are labeled with characteristics. Authenticator methods are labeled with factor type, such as possession, knowledge, or biometric, and optional additional characteristics like hardware protected or phishing resistant. Each authenticator and its authenticator methods are labeled with the attributes that were verified at enrollment. For example, an Okta Verify OTP enrollment will be labeled as a possession factor type, while an Okta Verify proof of possession key that was stored in a TPM and unlocked by device biometrics will be labeled as possession and biometric factor types with a hardware protected attribute. By using authenticators, admins can understand exactly how a user authenticated. Alongside authenticators to describe how the user authenticated, last year we also introduced the concept of assurance in our policies to leverage this rich information. Assurance gives you the ability to specify the authentication methods a user must verify before accessing a resource. Gone are the days of just saying prompt or don't prompt for factor. Instead, an admin can say, for this sensitive application, require the user to authenticate with at least 2 factor types out of knowledge, possession, and biometric. Additionally, require at least 1 phishing-resistant method. Okta's policy engine will prompt the user for the authenticators enrolled that allow them to meet the assurance requirements specified in policy. With this new language of assurance, compliance requirements like NIST are easily achieved with a check of a few boxes. Don't just take my word for it, let's see this all in action. Let's take an example of an admin user who logs into the end user dashboard for their day-to-day but has to sometimes access the Okta admin app. Here in Applications, we have exposed the Okta dashboard with an app sign-on policy that you can configure. I have it set so that the user can log in with any 2 factor types. The preview here shows the authenticators enabled in the org that can satisfy this requirement. When I switch over to the Okta admin app, an app that I consider highly sensitive, you can see that I've set the sign-on policy to require password and another factor, and that on top of that, the factor has to be phishing resistant as well. Let's see what a user would experience.
Successfully changed my password.
Here, as a user, I'll log in with password.
Successfully changed my password.
And then enter an OTP.
Successfully changed my password. Successfully changed my password.
I've successfully logged into my dashboard. However, when I go and click on Admin App, you'll see that I'm additionally prompted for a security key, a phishing-resistant factor, as specified by the Admin Console policy. The authenticators and assurance we launched last year are just the foundation. Now that we've introduced the concepts to describe your security requirements, we want to make sure that you can integrate any authentication method that your organization wants to use. For example, we've heard from many of you that you want to bring your own voice print authenticator, push authenticator, or risk-based authentication provider. Today in Okta, we have our custom claims authenticator, allowing Okta to call out to any external system via SAML or OIDC protocols to perform authentication and return a claim to Okta. In the authenticator world, we plan to allow admins to describe exactly what attributes were verified when the claim is returned. For example, a custom voice print authenticator can be represented as a biometric factor type. In addition to factor type, we plan to allow you to specify device assurance attributes too. If your integration verifies device management or device compliance status, then you can represent that in assurance as well. Finally, we will extend our integration capabilities to allow you to integrate multiple claims authenticators for as many integrations as your organization requires. Beyond defining static metadata, we will also add the ability to process the claims that are sent to Okta at the time of verification. When a user signs in using a custom claims provider or federates from an external identity provider, assurance will allow these integrations to communicate to Okta's policy engine. Okta can receive information about what authentication was already performed and attributes like device compliance status. Then, Okta's policy engine will process these claims against sign-on policy. Depending on policy, the policy engine can prompt for additional authentication as needed. In the example in this diagram, the user is federating in from an external IDP where they've only verified their password. The device claims provider assesses the device as not compliant. The policy engine sees that sign-ins from non-compliant devices require MFA, so Okta will prompt the user for that missing MFA. Looking a bit farther into the future, our goal is to provide the ability for third parties to publish their own authenticator in our integration catalog. All admins will have to do is add the authenticator and it'll be usable by your end users. The authenticator will already be integrated into policy with all the assurance metadata defined by default or via claims. Moving on to the next problem statement we've heard from you, more frequent policy evaluation. This past year in Okta Identity Engine, we've launched more flexible self-service password reset. We've heard that admins want to make sure that operations like password reset require a high level of assurance, and that admins want to require users to verify with stronger authentication methods. With this new feature, we've added an option for users to initiate password reset with Okta Verify Push. In addition, users can now use any factor as extra verification for password reset. This means that you can create policies where a user can self-service password reset with factors like Okta Verify and WebAuthn instead of requiring a security question. Here's a quick demo to see what we've built.
Let's take a quick look at the policy the admin has set. Here you see that password reset is set in policy rules, and the admin has allowed password reset with Okta Verify Push or email. For extra verification, the user can use any enrolled authenticator. Switching over to the end user, I'll click on Forgot Password. I see the option to get an Okta Verify Push, and you'll see the push notification go through. Next, you'll see that I can verify with any additional enrolled authenticators. Here I'll select security key, verify my security key, and I can successfully change my password.
Going beyond the functionality you just saw, we plan to add additional conditions to password reset. Today, we only have network conditions, but we know you want to integrate risk and device conditions as well. For example, only allow password reset when the user is on a managed device. Last, but definitely not least, we plan to expand to recovery of any factor, not just password. We've also heard that as admins and as developers, you have many reasons to prompt for authentication only when needed. This year, we plan to allow you to trigger a policy evaluation whenever you need to in your app. For example, this could be when a user does something like downloading a sensitive file. Okta will evaluate the authentication context, network, device, risk, and execute the policy that you have specified, stepping up or even denying authentication. While we plan to launch this feature initially with redirect flows, in the future, we will also build out transactional authentication as well. We also plan on building out integrations with your risk engine so that you can minimize user interruption and step up only when needed. Finally, going back to our core problem statements, let's take a quick look at what we're doing in the space of admin and end user visibility. This past year, we launched the end user recent activity dashboard to early access. This feature is accessible from the dashboard and allows users to view sign-ins and security events on their account. If the user does not recognize an activity, they can report directly to their admins by using our Report Suspicious Activity feature. This action will trigger an event that admins can subscribe to and run workflows on. Recent activity is really just the beginning, though. In the future, we plan for this page to be the place that users go to view and manage registered devices, as well as other security configurations on their account. We also plan to integrate with Okta's risk engine, highlighting to the user the sign-ins that appear the most unusual. However, we know that not every user will consistently check their security dashboard, and we want admins to have a way to reach all users. Today, admins can enable email notifications for end users to be notified on username change, password change, and other account activities. This year, we plan to extend these notifications to be delivered across more channels, including dashboard, plugin, and provide an API for custom integrations. Notifications will not only include Okta-generated notifications, but also custom notifications from administrators as well. Beyond 2021, we will send notifications to even more channels, such as Okta Verify Push. In addition to end-user notifications, this framework will allow us to send notifications to admins as well, to notify you whenever Okta detects abnormal activity in your tenant. So that's it for this section on the core policy engine. But before you go, in this session, You've heard from us on these three exciting areas: infrastructure access, risk ecosystem, and policy engine. We hope that we've left you with a little bit more insight on where Okta is going with our identity-centric approach to zero trust security. However, what we covered in this session are just a few of the exciting products Okta is working on in this next year. To learn more about our overall product story, we recommend checking out the sessions and recordings for all our other roadmaps. Thank you all for attending this session.